How to use AI to detect zero-day vulnerabilities in software. Detecting zero-day vulnerabilities, security flaws unknown to the software vendor, is a needle in a haystack problem because there is no existing fingerprint, signature, for the attack. In 2026, the shift has moved from simple anomaly detection to autonomous exploit chaining and generative bug hunting. Here is how you can use AI to identify these hidden risks. 1. Behavioral anomaly detection. Real-time. Traditional antivirus looks for known files. AI looks for abnormal behavior. By establishing a baseline of normal system activity, AI can flag zero-day exploits as they execute. How it works? ML models monitor system calls, memory usage, and network traffic. What to look for? A legitimate calculator app suddenly requesting network access, or a document reader attempting to modify kernel-level files. Tools, EDR, endpoint detection and response. Platforms like CrowdStrike Falcon or SentinelOne use behavioral AI to stop execution even if the malware has never been seen before. 2. Large language models, LLMs, for static analysis. The newest frontier involves using specialized LLMs, like Anthropic's Mythos or Google's Big Sleep, to read through massive code bases and reason through potential flaws. Automated bug hunting. Unlike traditional static analysis tools that follow rigid rules, these AI models understand context. They can identify complex logic errors and chain them together to prove a vulnerability is exploitable. Project Glasswing, a 2026 initiative where organizations use AI to scan open source and proprietary code, finding bugs that have existed for decades, like the recent 17-year-old RCE vulnerability discovered in FreeBSD. 3. Network detection and response, NDR. AI monitors network flow rather than just packet headers. This is critical for detecting zero days that use living off the land, LOTL, techniques, using legitimate system tools for malicious purposes. Lateral movement tracking. AI can detect when an attacker is moving from one server to another by identifying subtle shifts in data transfer patterns. Deception technology, AI can generate honeypots, fake targets that look identical to your real infrastructure, tricking zero-day exploits into revealing themselves in a safe, monitored environment. 4. Generative fuzzing. Fuzzing is the process of pumping a program with random data to see if it crashes. AI makes this smart. Smart payload generation. Instead of random noise, AI generates semi-valid inputs that are more likely to trigger deep-seated edge cases in the code. Evolutionary algorithms. The AI learns which inputs get deeper into the code's logic and iterates on those paths to find hidden crashes. Comparison, traditional versus AI detection. Feature, traditional, signature-based. AI-driven, behavioral/generative. Detection basis. Known database of threats. Deviations from normal behavior. Zero-day success. Very low, needs a patch first. High, detects novel patterns. Speed. Instant for known threats. Near real-time but higher CPU cost. Primary weakness. Useless against new malware. Potential for false positives. Strategic implementation. 2026 best practices. To effectively use AI for zero-day defense, follow this tiered approach. Deployment, use EBP, F-based AI tools like AccuNox for deep visibility into Linux kernels and containers. Validation, always use a human-in-the-loop, HITL model. AI can find thousands of potential bugs, but security researchers are needed to prioritize which ones are truly exploitable versus just bad code. Zero trust. Combine AI detection with zero trust architecture. Even if a zero-day bypasses the AI detector, A zero-trust setup prevents the exploit from accessing sensitive data. Expert tip. If you are a developer, integrate GenAI security copilots into your CI/CD pipeline. These tools can scan your code for zero-day-like vulnerabilities before you even hit the deploy button, effectively turning a potential zero-day into a pre-zero-day fix.